So we've talked about interest being compounded annually, which means that at the end of the year, you get interest on your principal and any past interest, everything that's in the account. So if your interest rate is 5%, then you get 5% of whatever you've got added to your account. And then the next year, you can make interest on everything that you had plus that 5%. Now that's compounded annually, which happens one time a year. You get 5%. But there's different compounding periods possible. You could have an account that was compounded quarterly, which at 5% interest would mean that you would take the 5% and split it up into 4 quarterly payments. So after 3 months, you get 1.25% interest. And you can already start making interest off of that the next 3 months, second quarter, when you make 1.25% interest, and so on. So you're making interest on that money sooner, the more often that you do it. If you read through page 99 and the top of page 100, they walk you through the development of our general compound interest formula. Here it is. This is for any number of compounding periods per year. We've got our same letters, A, P, R, and T. They all mean the same thing. We've got a new value, N, and that's how many times per year something is compounded. You'll notice it shows up in the formula twice. It's in the denominator, and it's also in the exponent. So if something is compounded annually, then that means N is 1. And if you plug 1 in for N, you'll find the same formula that we had before. If something was compounded semi-annually, that means it's compounded twice a year, and you plug in 2 for N. If it's compounded weekly, you plug in 52 for N. So number 6 wants us to look at these same numbers we've used before. A principal of 600, 5% interest. It's compounded quarterly for 10 years. And we want to compare it to what we get when it's just compounded annually. So I'm plugging in all my letters, just like I've done in the past. Notice there's 2 places where we plug in 4 for N. Quarterly means 4 times per year. And then I want to take care with my order of operations. So I plug it all in, and I get 986.17. If we compare that to what we got when we used an annual compounding formula, we can just subtract those 2 numbers and get the second answer that number 6 is asking for. Number 6 is asking what is the amount when it's compounded quarterly, but also how do they compare. So you just subtract those numbers and say how far apart they are. Number 7 says repeat question 6, this time using interest compounded monthly, 12 times per year, and interest compounded daily, 365 times per year. In each case, find the amount of interest that was earned, not just the future value. So what is this question asking us to find? It's the same scenario, same principal, same interest rate. We're just changing the number of times it's compounded per year. So what are they asking for? They're asking for the future value after 10 years, but also how much interest is earned. So we'll have how much the account is worth, but then we want to look and see, well, how much of that account just came from interest? So how are we going to come up with that? If we know what it is now, and we know what we put into it, and the only thing that's happened to it, other than in the meantime, is just that it's gotten interest, then we can just take the amount it's worth now, minus how much we put into it, and the difference is the interest, right? So let's try it. So if we figure it for compounded monthly, so now we're working on number 7. The only thing that's going to change is the number of times that it's compounded in. So instead of 4, now we're using 12. There are 2 places we need to fix this. 2 places where we see n. Oh, there we go. So down here, it's going to be a 12. And up here, it's going to be a 12. So why don't you pause the video, plug this into your calculator, and see if you get the same thing I get. Okay, so how'd you do? Is this what you got? So this is our future value when it's compounded monthly. If I want to find how much interest, I take how much I have now, or my future value. Maybe that'll write. Oh, maybe I need to not have the pen or eraser. Okay. So I take how much it's worth now minus the original, and that should give me how much interest I have, right? So 988.12 minus that $600 original amount, principal. And now I see how much interest I earned. I'm going to try the daily one using Excel as my calculator. So I'm going to copy and paste compounded quarterly. So it's the same, oh, it's not showing, there we go. Okay, so I want to use the same formula, but remember, I'm changing in. So with quarterly, I was plugging in 4 for n. You can see the whole thing up here, and here it's larger. So instead of 4 times per year, since it's compounded daily, that's 365. And then also in my exponent, 365. I wonder, there we go. Now you can see it better. So 600, my p, times 1 plus, here's that fraction, the r over the n. All the parentheses are closed, and then it's to the exponent of, oops, I changed the wrong number, 10 years times n, 365. Now if I want to find the amount of interest, remember I take what it is now, so 989.20. I want Excel to be a calculator, I've got to put equals at the beginning, minus that original investment, and there's my interest. So for number 8, they want you to look at this. You've got that compounded monthly filled in from when we did it by hand. But look at these numbers and see if you can come up with just a general principle of what's happening the more often you compound something per year. Now all of these were at 5%, but it was just how much we subdivided that 5%, how often it was compounded per year. What happens to our totals as n gets bigger and bigger? That's what they want you to think about and write about on number 8.